Hey guys, so I'm not feeling well today, so I stayed home. But today, you don't really need me, so it doesn't matter that much. So today we're getting good at using multiple units from class to solve one problem. Specifically, we'll be using an equation from the free fall unit. We'll be using those three columns from the friction and forces unit right before winter break. And we're going to be using the conservation of momentum, which we just took notes on yesterday. All three of these things together let us solve some pretty interesting problems that are real-life problems. More on that in a sec. So today what I want you to do, second period only, I want you to look through the daily bulletin. That is something that we have extra time in this period to do. So do that, please. Then, all of you are then going to watch the video instructions on how to solve case files. You should see the video for that. Well, you're watching the video for that, aren't you? Then, after that, you're going to solve case file number 1, which should be visible in your briefcase, underneath accident reconstruction, underneath that folder. All right, so the big idea with the accident reconstructions for the case files. If you are in a car crash and someone is seriously hurt or injured, the Napa Police Department or California Highway Patrol might be asked to come out and do an accident reconstruction. What they do is they take all the measurements they can of where the cars were when they started braking, where they collided, and all that sort of stuff. And then they can use that and physics to reconstruct what actually happened. Now, usually they don't get to be there right after the crash happened, and they almost certainly never get to see the crash happens. So all they get are some marks that are left on the road. So we are going to use that same level of information to figure out how accidents went. So there are three things that we're going to talk about for your case file reconstruction. The conservation of momentum, the stuff we just learned about, forces and friction, and constant acceleration. Now for us, the big focus is going to be on the conservation of momentum, which is, the actual crash. You will know 3 of the velocities, but you're only going to start knowing 2 of them. So for our first case file, it is an inelastic collision like the picture here. You will know, for instance, the final velocity and the initial velocity of B. And you're going to need to figure out the initial velocity of A. So if you know the masses and V final and VBI, you'll know all of this and that number, and you'll just need to solve for your unknown, which will be right here. Just like we did in class yesterday. All right, that part's not so hard. Except, I'm not going to tell you these velocities. You're going to have to solve for them. And the way you're going to solve for them is using the tire marks. So when you slam on the brakes, you're going to lay down tread on the ground. Those skid marks, the length of that, is going to be what's going to tell you how fast the cars were going. So hopefully you remember these 3 equations. Net force equals mass times acceleration. Net force is applied force plus friction force, except there is no applied force when you're braking, so F net is just friction force. And friction force equals coefficient of friction times normal force, where again, normal force is the mass of the car times 9.8. All right, so you're going to do all of this, and you're going to solve for the acceleration of the car. It should be negative because the car is braking. Then you're going to plug it into this equation down here for A. And you're going to plug in the length of the tire marks in for X. And then you should be able to plug in one known velocity. You'll know one of them. And then you can solve for the other one. Now, if those skid marks are from before the crash, then your VI in your equation is going to be the velocity of the car before it starts braking. And the VF is going to be the velocity of the car right before it crashes. Now here's the confusing part. Your VF in this equation is going to be your VI in the conservation of momentum equation. So make sure when you're drawing your pictures that everything is labeled nice and clear. All right, and X is the length of this tire mark. Now, If those marks are from after the crash, it's easier because we know the final velocity. It's 0 because you skid to a stop. So that part's easy. We know that V final is going to be 0. We know A, the negative acceleration from the last slide, and we know X, the length of the tire mark. We just need to solve for the VI here. Except here's what's going to be confusing. The VI here is the velocity of the wreck right after the crash, which is going to be V final in your conservation of momentum problem. All right, that's a lot of stuff there. I know. I'm not expecting this problem to be easy. This is why I'm giving it to you in your groups. But I want you to use your notes and these sets of instructions that I've given you, specifically this picture, this, and this. Make sure you have those on hand easily so you can solve the problem to the best of your ability. Don't worry about making the report. When I come back, hopefully tomorrow, what I will expect to see from everyone is an answer. And I will ask you to defend your answer. You'll need to tell me why you think that. All right, there you go. It's a hard problem. I am curious to see how well you guys are going to do. I have faith in you.